In this video, I'm covering the use of a gray code. Now, looking at this diagram here, I have position numbers 0 through 15, and then a normal binary code for comparison. So this is just converting the decimal number 0 to binary. Over here, decimal number 9 to binary 1001, and so forth. A gray code is different because you use a scheme where when you make from one position to the next in a sequential fashion, like going from 0 to 1, you notice only one bit changes at a time. Okay, so in this diagram, the bit that's in orange is the one that has changed. So starting at the top here, when you went from here to here, this most significant bit is the one that changed to a 0. Okay, from 000 to a 1, only one bit changed. From 001 to 0011, only one bit changed. Okay, so that's the idea, that when you move in a sequential fashion with a gray code, only one bit changes. All right, so this is showing a 4-bit gray code. You can have longer length gray codes. You can have a 3-bit gray code. But the point is only one bit changes as you move in a sequential position. Okay, so a useful thing for this is, or useful application for a gray code is a code that you can use to represent the position of a rotating shaft. So in this picture, let this spin for a while. You have a shaft. Well, this is actually supposed to simulate a shaft rotating, but actually it's the sensor that's rotating. But you get the idea. You could envision this shaft rotating, and you're reading off various positions. So I'm going to hit the stop button here. Okay, and so when we stopped, we see we're highlighted on 0, 1, 1, 1. Okay, so 0, there's no light color there, no blue color there. 1, 1, 1. Okay, so it's just slightly reading that. So do you see the advantage of that? Because only one bit changes at a time, we don't have a transition phase where you might get the wrong answer. Okay, so an interesting case is when we look at, say, this location for 7. Okay, so in binary, 0, 1, 1, 1, if you move to the next level, what happens is all 4 bits change. Okay, so that means, unless they change at exactly the same time, there's going to be intermediate values that show up. That's what this box means in this diagram. If you go from 0, 1, 1, 1, you'll eventually get to 1, 0, 0, but in the meantime, you could have possible misreads depending on how the sensor reads these. They don't read at exactly the same time, just the physics of it changes it, where you have erroneous things that temporarily show up at the output. So that's a common reason for using gray coding. All right, it turns out we use gray codes for other things. Later on, we're going to do Karnaugh maps, and so you need to know what a gray code is. It's just simply a code that when you move sequentially, only one bit changes at a time.